thank you for joining us again on this second in our series looking at timber. Now, today I've got some toys with me. Look, I've got a moisture meter and I've got a jug of water, and we'll find out what this is in a minute. Salt, why that, and a bit of timber. Rich, have you got anything with you?
I've also got a big chunk of my roof, my 300-year-old roof, and I've also got another different type of moisture meter, which we're going to be covering in detail about how they work later on. So pay attention, people. This is going to be exciting. We've got some toys.
I hope that isn't freshly cut out of your roof anyway.
No, not freshly cut out. And the roof's still standing, so I think we're all right.
Oh, good. Right, okay, so what we're going to be looking at today is why is my wood rotting? And we're going to focus on what causes the timber to rot and how we might be able to prevent it from rotting in the first place. So that's what we're doing. So we're going to demystify rot. Is that right, Rich?
We are, indeed. So we covered in the first episode all about what timber is, what it's made up of, and everything else. And the whole purpose of what this episode is going to be is about talking. It's not some sort of magical chemical reaction why wood rots. It's actually and it's not a sort of spontaneous disease that it gets. It's actually the symptoms of the dampness that we have are all about biology. And we're specifically in this episode talking about fungi. We're going to cover insects in a future episode, but we're talking about the living organisms that actually feed on the timber in that carbon cycle that we explained in the previous episode. They're simply doing their job of using the dead wood as a food source, bit like what they find on the forest floor in that sort of carbon cycle that we covered before. Now, we need to establish that there is a golden rule here, and this is going to be a thread that's coming out all throughout this episode and in future episodes, which is about the fundamental thing about how we can control the rate of decay or the rate of rot for these particular timbers. And that's actually about moisture and environment, which we're going to go into more detail. Over to you, Stephen.
Right, well, I think the first thing we need to talk about is how do we find out if a piece of timber is wet or not? Is it dry? Is it wet? What's happening to it? Now, I think most of our viewers and listeners would have come across surveyors. If they've sold a house, they would have come across a surveyor coming in and waving around one of these. And I'm holding up a damp meter. This one happens to be a Protometer Survey Master. It's a few years old now. Now, you get a surveyor coming in, and these have got prongs, pins at the end, and they shove them in the wall, make a load of holes in your wall. And they go away and they get readings, or it bleeps, and they say, "Oh, you got damp. And and I have seen on YouTube in recent times and on other social media where people have said, "Oh, you need to throw away the damp meter. It's a load of rubbish. It doesn't help you at all." What we're going to talk about very briefly here is the fact that this is a tool. That's all it is. And the tool is only as good as the idiot using it. And so in my case, it's okay. But anyway, so I just want to demonstrate briefly what it's about. So my one's got two modes, the pins, and it's got a sensor at the back, which is, let me get this right, it's a radioactive, no, it's not radioactive. What is it, Rich? I've forgotten the term myself.
It's a capacitance meter, and that sends out radio frequencies, which then measure the different dielectric properties of what is below the surface. And I can come on to that a bit more if you like later.
Brilliant. But it just emphasises that I am a very simple building surveyor who hasn't a clue most of the time. But anyway, so here we go. So I put it on, and immediately I see a light come on, and it says here, you can't see it on your screens perhaps, but and for our listeners, I'm telling you that what it's showing me is WME, and that says wood moisture equivalent. So what does this mean? Well, all this is it's measuring electrical resistance. So, for example, if I put it on, at the moment it's reading 0, nothing at all. If I put it on my finger, all of a sudden it's reading 21%. Well, I'm about to rot. Or others might say, yeah, you're just a big drip, Stephen. But anyway, so That's all it is. It's just measuring the resistance, electrical resistance between those two prongs, and it's calibrated to be used in timber. So it's as good as useless, really, in plaster. You can use it as a comparative way, but you can't use it to tell absolute moisture. Now, I've got a bit of an old fence here. It's only a bit of slender piece of timber here. And there, you can see it's got some end grain there, which I think in our last episode we talked about end grain and side grain. Well, if I go along the timber and put this in somewhere along the timber, it reads here. So, for example, it's reading 12% there. Okay. Now that's 12%. Here it's reading 11%, so it's dry there. When I get up to the end grain, bearing in mind I only brought this in this morning, it's been out in my garden, the end grain is reading 13%. Okay, so what I'm going to do now is take this jar of water and put it in there. Okay, simple as that. We're going to set that aside. Now, Rich, why don't you talk to us about the capacitance side? And I'll come back to this and see what's happened in a few minutes.
Sounds good. Just before I do that, just building on the electrical resistance side of things, I want to cast our minds back to the previous episode about how we can use these as a reasonably accurate measure of moisture in timber and timber only. It's because of the lignin and the, what's the word?
Cellulose.
Cellulose
and hemicellulose.
And it's because of the consistency of the chemicals within them, i.e. the carbon, the hydrogen, the oxygen of those, which means that over basically thousands of experiments, scientists have come up and sort of said, actually, the moisture content affects the resistivity between those fairly consistent chemical compounds. And that's the really important thing here, which is why these moisture meters can be calibrated to work with timber. That's why it's called the wood moisture equivalent. Now, we also have to bear in mind, as we covered in the previous episodes, many different types of timbers, hardwoods, softwoods, etc. So some devices, and I've blooming well lost mine because I've got a device that just does measuring of timber because I use it for measuring the moisture content before I put it on my log burner, where you calibrate, or at least you select what type of timber you have, whether it's pine, whether it's oak, whether it's maple, etc. Because then that slightly adjusts effectively the brain within it to say what this resistance meter reading is going to be showing in terms of the moisture readings. I just thought I'd just build on that because as you covered, when you're pointing it at bricks, masonry, plaster and everything else, there's so much variation of the chemistry that's going on within that building that you can't have an accurate moisture reading on that particular substrate. It is only calibrated for timber. But let's go on to these capacitance meters then. So I've got one here, which is just a fairly cheapish one. But as you'll notice on the back, it's just got this pad. And building on what I've just mentioned, it says on the back here about measurement range. Now, this one's got a setting for softwood and for hardwood. And it says on here, measurement range, 0 to 53% moisture in softwood, 0 to 35% moisture in hardwood. So it's measuring percentage in wood. It then goes on to says relative readings in wall and masonry. That's a really important point. So what you can use this for is going around a masonry wall, and you can do, like Stephen said, build up a pattern of moisture, but it won't give you an absolute moisture reading. So putting this on the wall in one patch and sort of saying it's wet is nonsense. You have to then understand where that's wet in relation to everything else. But just on this meter in itself, I'm going to set it on from wall to masonry to softwood to hardwood. And I've got my chunk of oak here, which is pulled out my roof. And we'll cover in later episodes. You can see some lovely holes on the side of that. And you can see the different size. And you've got a bit of furniture beetle there and death watch. But we'll use this prop later in future episodes. But if I just stick this capacitance meter up against here, and hopefully you can see that for the YouTube viewers, see that's saying that's got 15% moisture in this. Now, the way this is working, this is actually sending out a small radio frequency to the first couple of millimeters of thickness of the timber. It doesn't penetrate very far. And what that's basically doing is measuring how much it bounces back. And by determining the resistance, if you like, of those radio frequencies returning back, a bit like a radar, I suppose, it's then determining for you what type of resistance in a timber, i.e. oak or hardwood like this, that you're going to get. But as you see, as I move it up and down this thing, I've got a bit of a variation. Now, bearing in mind, this piece of timber was cut out my roof 8 years ago. It's been in my dry garage since, and it always has been a relatively dry piece of timber, albeit that the insect attack will tell you otherwise. But you can see there's still variation across it. Oh, I've even got it to beep. There we go. So that's gone up to 18% on that spot there. Now, there'll be an element of, within this timber, there may well be some bits of metal. There may well be some other foreign bodies in here. So there may well be still some dead larvae in here, potentially, which is going to sort of throw this off. So the point being, even with these meters, you're going to need to be a little bit conscious about what they can tell you, I suppose. Go on, Stephen, you were going to say something.
Yeah, the other thing is, you talk about your piece of timber giving you a reading there. We've got to remember that timber is itself hygroscopic. It will absorb moisture from the atmosphere. That's what it will do. So when the atmospheric moisture increases, the timber will absorb some of that. And so day to day, hour to hour, you could get different readings from a piece of timber. So anyway, going back to my piece of fence post dunked in my water here. So it's been in the water a few minutes now. So that end, as you can see, is nice and wet. I go back to the dry bit and it's still reading 10%, what have you, and it's 10%. Now we get to here and all of a sudden it's gone up to 25% there, near the end there. And yeah, 27, 28%. And it's in, sorry, I'll reverse this round. There you can see it's in the red. Okay. Now, does that mean that this timber is going to just rot because it's now very wet and I'm getting a very high reading on this? And the answer is no, because I've now removed it from that source of moisture and it's got the potential to dry out. So this is what we're going to talk about, is why timber does rot and how we can stop it rotting and the importance of this controlling moisture. So going back to the meters, though, just to finish off on these, when you see a surveyor getting out one of these, don't panic and say, oh, we shouldn't be using one. It's not a matter of she shouldn't be using one. It's a matter of how it is used. I have surveyed a lot of timber frame buildings, and when it comes to assessing whether there is a risk of a timber in a frame rotting, these can be very useful. However, I wouldn't be using it necessarily as an absolute reading, and I certainly wouldn't be using it as an absolute reading in a wall. So I might use it on a skirting if I suspect that there could be rot in a skirting, but it looks okay, but I'm a little bit suspicious. Put this in, get a high reading. It might be damp. There could be a problem, something worth looking at. So that's how you use these meters sensibly. The other thing we ought to mention is how these meters can be fooled. Now, there are many different materials in substances, surfaces. So, for example, some bricks can contain elements within them that will give you a false reading. Some walls might have foil-backed plasterboard. And so if you poke these in, you're going to get a reading. Doesn't mean to say the wall's wet, which is why you can't rely on it as an absolute. Now, I have here, as I think I showed you earlier, a little bowl of salt. Now, I'm going to shove this in. Now, bearing in mind, this is zero air, nothing. Put it in the salt, and I'm now getting a reading. I don't know if you can see it there, but it's about 14%. Okay, so that's 14%. Now, going back to my timber, at the moment it's reading 26% on my timber. What I'm going to do is sprinkle a little bit of salt on there as well. Let's see if that makes any difference. So I've now got a bit of wet timber with salt on it as well, just to confuse matters even further. Now, what's the reading I'm getting? Oh, it's turned itself off. Here we go. Now, all of a sudden, 89, you can't quite see that, 89%. It's suddenly gone up. That salt has caused it to go to 89%. So that just shows you how these reasons. Is this going to rot? No, it's not. But that reading would suggest it should be falling apart, but it's not. So that's how these can be fooled.
And that is one of the advantages over this type of capacitance meter, is that actually it isn't spoofed by salts, but it is still spoofed by surface condensation and also by foil back plasterboard and everything else. So there isn't a panacea out there in terms of device that is absolutely perfect. So it's just knowing how they work is really important to know how they can be used.
Okay, I think it's important now that we've gone through the use of the moisture meter that we talk about the actual danger zones, the amount of moisture that is a problem or isn't a problem. So, Rich, do you want to just talk us through the zones for decay, as it were?
Certainly can do. As Stephen mentioned before, timber being hygroscopic, which means it absorbs moisture from the atmosphere, then when the humidity then decreases and re-releases it back out again. So it's entirely normal to have a level of moisture within the timber. So these timbers behind me that you can possibly see, I mean, these have got a level of atmospheric moisture within them, which has been absorbed through the living and breathing and everything else in this house. But the normal kind of boundaries that you would expect from that, which you can use your pronged moisture meter in these timbers up here, for example, should be between 9 to 12%. That's of wood moisture equivalent. So that's 9 to 12% moisture content on these meters that we've got. Below around sort of 16%, the moisture content, the fungi just has no ability to grow, to thrive. And we're coming on later on in terms of what fungi actually needs to grow. But at the moment, the threshold is below 16%, 20 to 16%, there is no ability for that fungi to thrive. I mean, it may grow slightly, but it won't continue to grow and exponentially increase. The risk zone starts when you get that moisture content above about 20%. That's where fungal decay becomes possible. That's when it starts feeding the fungus to be able to then start growing, and as we'll come on to. The real danger zone is when you get fiber saturation. So what that is when you get above around 28% or 30% moisture content, that's the point when actually the timber's cells are completely full. So the actual cell organisms, the cells within the timber itself, are actually full of moisture and what's known as free water, if you like. It starts pooling within the cell cavities themselves. And that then provides effectively the drinking water for then fungi to then thrive. And it's at this saturation level, which is then you get the significant structural decay. But I need to kind of reiterate here, this is about persistent levels of moisture, not about moisture like Stevens just demonstrated, dipping in that cup. That moisture level is over 25%, but it's not persistently over 25%. And there's another really important ingredient, which we haven't covered yet, which is also needed with the moisture content, which we'll come on to.
What we need to think about now is, what do the fungi actually do? I mean, I've always explained to clients when they've asked about fungi that effectively it's like a mushroom, really. It's just another variant of a mushroom that requires certain things. If it's in the right conditions, it'll thrive and you'll get a load of mushrooms. If it's not, they'll die off and they'll go away again. So that's a very simplistic way of looking at it. So, Rich, tell us more about fungi, what they actually do, what they are, etc.
So essentially what fungi is doing is it's using the cellulose and the lignin that we've heard about in the previous episode to break it down as a food source. And it actually has enzymes within it, within the fungi, that break down those structural components, which is why we end up seeing the decay as it is. It actually, you see it shrink, you see the cuboid, you see the cracks that form with it. And it's because of these enzymes that are breaking it down, because it's using it as a food source to grow the fungus so it can then thrive. Fungi actually grows with the hyphae, which are kind of the microscopic threads that actually physically penetrate through the timber's cell walls. Now, these threads then mass together to form a network, which is then called the mycelium. Now, eventually they produce the fruiting bodies or the mushrooms or the brachy, which then release spores, which then thrives and then goes on to other timbers and all the rest of it. Crucially, for fungal growth, we need 4 ingredients, and we've touched on a few of those already. So the 4 crucial ingredients are, you need the moisture. So the timber must be over roughly around 20% moisture content persistently, not just moisture above 20 then drying out. It's got to be persistent moisture above 20%. It needs oxygen. It needs a suitable temperature because it typically is between 5 degrees and 40 degrees. It doesn't work at below freezing. Like, we wouldn't function very well at that. Actually, it needs a little bit of warmth and needs a food source. And that food source, of course, is the carbohydrate within the wood. Effectively, it's that cellulose and that lignin that it's breaking down. So you establish this golden rule, which is if you remove any one of those four things, you don't get the fungi growing. Like, it stops dead in its tracks. It can't do any more. Now, notice within those four things, I haven't mentioned anything about any kind of chemical attack or anything that can kill it. It's those four fundamental things which will stop the fungi from growing. If you take, for example, a ship's hull, or if you think about some of the timber that is completely submerged underwater, like in Venice, you've got various structures that are built on it. You'll notice that within those, they haven't rotted. The place where you start to get and you see some of the decay and the rot are the places that are wet then dry, or persistently wetted, but still have access to oxygen. So just above, for example, just above the waterline on a timber ship's hull is where you get some of the decay happening. But you don't get it below the waterline. That lasts a huge amount of time. And as we've probably noticed that's outside in our garden space, if you've got a tree that's fallen over your garden, it takes a heck of a long time to rot, but it rots from the bottom. It rots where essentially you've got that persistent moisture and it can't dry out. So what we have is what's sometimes referred to as the Goldilocks zone, which is where fungi that needs the perfect balance of dampness or persistent moisture, that's oxygenated, so access to oxygen so that it can still thrive, and it needs to be a certain temperature with the food source that we've covered. If you have all of those, then you've got the conditions for decay of fungi. Sorry to interrupt, folks, but before we continue, I'm just going to give a quick note about a service that I'm part of, which may be of use or interest to our listeners. Expertible is designed to give homeowners truly independent guidance when they're facing problems with their older property. Through Expertible, you can choose a specialist consultant, like with my co-host here, Stephen, and you can book a one-on-one video call. In that call, you get clear, unbiased advice about what's going on and what your next steps should be, without any pressure to buy services or products. It's a straightforward way to understand your options before committing to anything. So if that sounds useful, do go and take a look on expertible.com.
Can I add one thing, Rich?
Absolutely.
I've often heard it said, and there are lots of people that believe this myth, that if you get dry rot in one part of a building, then before long it's going to go through the whole building and it's going to wreck the whole building, destroy the whole building. That's completely wrong. People used to believe, and I think some people may still believe, that these fruiting bodies and the mycelium that Rich has mentioned can transport moisture to wet up a dry piece of wood and then cause it to rot. They can then grow in, feed on it and grow on it. Now, whilst it's true that the mycelium does transport moisture around, a bit like roots for a plant, it takes the moisture around to feed the growth. That's true. But there's not enough moisture being transported in there to wet up a dry piece of timber. So if you've got an outbreak of rot in one part of a building, where you have dampness and moisture and the conditions that Rich has just spoken about, it can thrive. However, even if those spores or the mycelium grow to a zone outside of that, to where there aren't those four essential elements, then it will not thrive and it will die out. And so this myth of it just invading a building and spreading within months from one corner right the way through the building, absolute rubbish. If the building is sopping wet, then it might happen, but that's very rarely the case. It's usually very isolated. I just thought I'd knock that myth on the head because I think it's an important one.
What I would also add, which I didn't mention, is that the spores of mold are omnipresent. They are with us throughout everywhere. And it's not about having eradicating the spores that they don't then grow into these dry rots and various other things, which we're going to cover in future episodes. It's about if the conditions are there for the spores to germinate, your moisture, your food source, your oxygen, etc., then they will. It is not about removing the spores. You will have to hermetically seal your building and not live in it as a human being, quite frankly, to be able to then remove all the spores. So it is not possible to go in and coat a building with chemicals that kill the spores and everything else, because within days, weeks, they'll be back again. And that's just impossible.
I totally agree. In fact, years ago, when I was learning about building conservation, I went to some lectures by Brian Ridout, who's well known for looking into this whole area of rots and infestations. And he was saying how difficult it is in even where they're trying to grow it for experimentation, they struggle to get it to grow. So it doesn't just easily grow anywhere. It needs the right condition. One of the things that we've often spoken about as being almost like the silver bullet that's going to cure all your problems is ventilation. We need to ventilate. And as a simple surveyor, in the past, and I would still say that ventilation is important, and just simply ventilate voids, ventilate this, ventilate that is important. Yes. However, I think too often, and this applies to us surveyors as well, we don't actually think it through. We don't understand what ventilation is really about. And actually, recently, a few years ago now, there was a bit of a study that came out, and it was quite controversial, and it's been sort of rejected now. But what they were saying is you don't need to ventilate floor voids. And what they were saying is that, we don't need the sort of ventilation everyone's talking about. And I think that's been shown to be untrue, because we know that we do need airflow. However, I think what they were getting at and what they were touching on in that was that there isn't just ventilation that suits everything. There's good ventilation and there's bad ventilation. So I just want to just touch on that. So ventilation helps when the fresh air you're introducing has the capacity to absorb moisture into it and then take that moisture away. So you need the air coming in to be drier than the air within the void. Okay. So if it's the other way round, then that air coming in is actually just going to exacerbate the problem. So what you need is dry air coming in to then absorb the moisture, and then for that ventilation or airflow, and I think airflow is perhaps a better term here, because we want a flow of air, because we want that air to come in dry, to go through the space, absorb moisture, and then exit the space. So that's what we're actually doing. We're bringing dry air in, absorbing the moisture, taking it out and taking it outside. That's good ventilation. Bringing wet air in, or bringing any air in to be absorbing moisture and then it can't get out again, that's a bad thing, because you're just going to exacerbate the problem, as I said. So therefore, we need the right sort of ventilation, and it is dangerous to have ventilation that is going to create more of a problem. Now, in terms of timber, where's this going to matter? Well, there are two areas in a building: roofs and floors. Now, roofs are generally quite well ventilated naturally and usually aren't a problem. I tell you when they do become a problem, though, or two scenarios I can think of is one where they are lined, and two where you've got some sort of insulation in the wrong place in a roof void. And then you can create a problem of atmospheric moisture that's too high. You're bringing in ventilation, but it's just creating a problem. What I really wanted to focus on is subfloor timbers and the areas below our feet, and usually on ground floors. It doesn't usually affect upper floors because they're in a dry atmosphere within the building. But on the ground floor, what we've got is a void where the timbers are above a void, and then you've just got the soil or the overground, and therefore the potential for ground moisture to come in and cause an atmospheric moisture issue within that void. So that's where we need to think about venting into that area. So that's a very brief overview. But what we're talking about is having dry air coming in, wet air going out. We need that airflow. Do you think I've discussed that sufficiently, Rich, or do you want to add anything to that?
No, I think you've covered it. I mean, I like to use the kind of the physics of the action of drying, if you like, and sometimes air movement is often ignored to a certain extent, or at least not well known. I mean, it's the kind of thing where if you lick your finger and hold it up, how long it takes to dry, whereas if you lick your finger and then blow it, you feel the coldness, and that's a separate issue in terms of the latent energy that's being sort of incorporated into the energy. But it dries much quicker because of that airflow past it. And it's the same with trying to get our buildings to dry out. Now, the bit that I would come on to then is about forcing drying can sometimes be a negative thing. So natural background ventilation and drying is a good thing, but if you have too much airflow or even applying too much heat, that can actually slow things down in terms of that drying process. The physics behind that is about understanding about using things like dehumidifiers and blast heaters can actually have quite a negative effect on when you're trying to dry something out. This actually is quite evident in flood remediation companies, where if you've suffered from a flood and you chuck in a load of dehumidifiers and heaters and you come back and declare the building's dry, only for then weeks to go by and you then find actually it's still sopping wet because of the bit I'm going to describe. This breaks down into effectively how substrates and how things dry out. And there's what's known as stage 1 and stage 2 drying. Stage 1 being the liquid capillary flow to the surface. So in other words, a saturated substrate will then have a liquid flow paths where all the bits of capillaries and tiny tubes will link up, which then has a negative vapor pressure on the exterior, which will then effectively suck like a straw that liquid water through the substrate to then dry out. That's stage 1 drying. Stage 2 drying is the much more slow vapor diffusion from the core. So that is your water vapor gradually finding its way through the substrate to the exterior. Now, the problem is when you are blasting or when you're having a very, very strong vapor pressure gradient on the face that you're trying to dry out, either by heating it or by dehumidifying it, you can actually break that capillary draw. In other words, you break the surface tension of the water that's formed in that straw. That's what can fundamentally happen. The inside core stays wet, but on the surface, it seems dry. So it's really quite challenging to then balance not just ventilation, but not force the heating of these things when it comes to sort of drying out the timbers. So the general rule of thumb is that drying actually has to be quite slow and quite steady, and gentle background heat and good ventilation is what's going to then remove the water vapor that's evaporating from the timber that we're talking here, as opposed to trying to force it. You can imagine these huge big thick beams above me. If they were absolutely saturated, I could get a hairdryer and I could dry the surface and go, brilliant, that's dry. But it absolutely won't be, because you know that it's going to take quite a long time for that moisture to actually permeate to the surface to then evaporate naturally. That's essentially what we're talking.
So really, if you're talking about drying out timber, you want a little bit of a mix of heat and air movement. So, and that's why when you're talking about flood situations, they'll often put heaters in as well as the dehumidifiers and so on and so forth. And okay, yes, it can accelerate too fast, the drying out process, but the principle is there that what you're trying to do is heat the air to the point it can absorb moisture, because that's what you want it to do. You want it to absorb that moisture, but then you don't want it hanging around. That's where you want that airflow. So it's that combination of airflow and some heat. Is that right?
Absolutely right. And I think this kind of brings me on to another term that people talk about with the kind of the dry mechanics, which is that of, oh, well, you just also need to make sure the materials that are used are breathable. Now, I fundamentally get an ick when I hear that word, and it actually makes me sort of itch very slightly, because it's not scientifically defined, and it very much annoys me when I hear. I mean, I might put several people off here because lots of people use the word and everything else, but I think it had its place in its day. But now, when we're talking about specific scientific and measurable outcomes for materials, it is a word that has become synonymous with marketing, and it's about trying to convince people that is a suitable material for using a building. specifically when we're talking about breathability, and I'm trying not to use that word as much as we can, there are three main criteria, and this definitely applies to timber, that we need to consider, which is its vapor permeability, which is therefore the ability for water as a gas to diffuse through the particular material. There is the hygroscopicity, which we've already covered, which is about the timber's ability to absorb moisture at levels of high humidity and then desorb and then let it evaporate when that humidity decreases. And then about capillarity, which I covered just earlier on, which is that's the physical wicking action of liquid moisture passing through it. So I've covered those in some of the other bits that we've discussed already. And those three elements are what make up what's really important. And that's what makes timber such a fantastic building material, because it has all of those three components to it. Now, I wouldn't go and classify a timber as being a breathable material. What I would say is it has good vapor permeability, it has hygroscopicity, and it has a capillarity. Stephen, what are your thoughts on the word breathable, I suppose, in itself? I mean, yeah.
Well, I suppose I'm as guilty as the rest of having used the word. I still occasionally slip in and use the word and think, oh, I shouldn't have used that word. We got so used to using it over the last, it's a term that was brought about in the 80s, I think it was. I think actually, I hesitate to say this, was it the Society of Protection of Ancient Buildings, SPAB, the need for old buildings to breathe? And I think they brought out a leaflet in the 80s that said that. And it was very useful. It was great because it opened up that discussion about moisture movement and how buildings need to work with moisture and manage moisture. But of course, in recent years, buildings don't breathe. They don't inhale and exhale, not like we do. And therefore, we need to start moving away from that as a term. Anyway, we've done a lot of science so far, and which is all good. But I think what some of our viewers and listeners will want to know is, well, this is all great stuff, fascinating, interesting stuff. But what do we need to look for? What are we looking for in our buildings? And so that's what we're going to briefly talk about now. We've already said that one of the key components of timber being broken down and deteriorating is moisture. So the first thing I'm going to mention is moisture. Staining. Look for stains. We've already talked about using a moisture meter. I'm not saying don't use one. I'm saying if you see a stain and you think, is it damp, is it not? Then this might be useful in not identifying whether it's wet or not, but identifying whether there's a real difference between an area of wall or an area of timber that hasn't got a stain and an area that has got a stain. So you're just trying to get that differentiation. Then you have to start saying to yourself, well, have I got a leak somewhere? Have I got water penetrating? What's going on? Is there water there? Now, timber itself, I'll bring back my piece of, I'm just going to wipe the salt off it, off the surface. But here, that's the dry bit of timber, okay? That's the wet bit. The wet bit's darker. So there's a difference in colour there. So the other thing to look for in timber, if you've simply got a piece of timber, is to look for change in colour. Now, that's something you need to get used to looking for because timbers do change in colour. It's a natural material. It'll have colour variation through it anyway. But if you know that particular piece of timber suddenly looks as if it's getting darker, you have to say to yourself, well, is it because it's getting damp? The next thing is that will then lead to staining. It'll lead to peeling paint and so on and so forth. So those are the sort of superficial things to look for. The next thing that will happen is as the timber deteriorates, it will weaken. As it weakens, it loses its capacity to bear load. And as that happens, you're going to get sagging and distortion. You might find that cracks start to open up. We're going to be talking about movement in buildings separately. What you've got to try and differentiate between is that crack due to a more general structural movement, or is it because there's a timber somewhere nearby that has failed, that's starting to crush out because it can't take the load. So the masonry or whatever is above it has started to drop, and therefore you've got a crack. So it's looking for these defects that could indicate a timber that is deteriorating and lost its capacity to bear load. Now, some of these timbers will be buried in the walls. Some of these will be buried, concealed timber lintels above windows. They could be timber grounds within a wall, especially within Georgian and Victorian buildings. They often put timbers in, sometimes as a fixing for skirtings and panellings and things like that. But you'll find timbers throughout your walls that you probably didn't realise were there. Now, if they're getting wet and rotting, they're going to crush out. You're going to get movement. So look for that. Now, with the timber itself, you're also going to start seeing some damage to the surface. You're going to start seeing distortion to paint on the surface of timber, or the timber itself is going to start to look as if it's cracking, as if it's starting to break down. And there are different things to look for. We often talk about cuboidal cracking, where the cracking looks as if it's in little squares. And sometimes it's more fibrous and long, and you start seeing the grain open up. And that's a different type of rot, but that's also a sign of rot. So these are all indications that there could be rot affecting those pieces of timber. And this is what I, as a surveyor going around a building, will be looking for. I'll be looking for these indications. And sometimes I'll use one of these moisture meters to assess, is there a problem? Isn't there a problem? Again, not absolute moisture content, but just to help me, guide me. And there are other things that we can use. We can use thermal imaging, can be used, because anywhere that's damp will be colder than anywhere that's dry. So thermal imaging will show us where the cold spots are. And that can be a guide as well. And if you've got things like a boroscope or an endoscope, you can look through cracks and little gaps and things to get behind. So those of us in the professions have the tools to enable us to investigate these things properly. So if you're suspicious, then you call in someone to independently assess what is really going on, where the problems lie. And then finally, and I'll shut up after this one, the final thing is to actually look for the mycelium, the little growth, the fibrous roots that start to come out. If you start seeing little fibers, it looks like black cotton, a little like lacy type black cotton creeping across the face of a timber. That could be an indication. If you start seeing like an orange dust on surfaces, that's an indication, because those may be the spores that are coming out. The rot may be releasing spores to propagate itself. These are some of the things to look out for. And of course, if you see a growing body, a fungal body, then that again is clearly an indication that something's going on. Just a little bit of a word of warning. I was recently doing some footage for a training video, and I was working with a friend of ours, Peter Monk, who is a timber and damp specialist, and we'd opened up this floor void and we came across these fruiting bodies, and we were both sitting there saying, well, what is it? And neither of us could actually identify it. And anyway, we took it away and we looked at it, and it was just a puffball mushroom. That's all it was. It just happened to be growing in the floor void. It wasn't rotting any wood. It was living off some timber that was already rotten and some paper that had got under there, but it wasn't fruiting body of a rot as such. So one has to be a little bit careful and identifying these things. We're going to be talking a little bit about the differences in a separate episode, and we're going to be talking about this in a little bit more detail. But hopefully that's given you some idea of the sort of things we need to look for.
What I want to now know is, did you whip it out of the floor void, slice it up and stick it on a frying pan and have it for lunch?
Apparently the one we found was edible.
Was it?
But, yeah, apparently it was. That. But we weren't going to try it.
No, thanks.
It didn't look healthy.
No, I was going to say.
Excuse the interruption. Just to say that if you're finding this episode useful, you may want to explore some of the wider work I do. To help shape and deliver conservation-focused learning for practitioners at all levels, I co-founded Best Training. I also offer one-to-one mentoring for professionals, as well as site visit walk-arounds and practical line experience days. These are all designed to build confidence and deepen understanding of traditional materials and building behaviour. I'm also a consultant on Rich's platform, Expertible, that you've heard about, where you can book a session with me. If any of this interests you, have a look at my website, beconservation.com.
I think one of the things that I have no experience of whatsoever, but I have read about, is some of these very, very clever devices that drill a really tiny hole through the timber and measure the resistance of the drill going into it. Have you got much experience of using those, Stephen? Because I mean, that would be really interesting as well.
Well, I mean, the first thing, if you're the first stage of investigation, once you've established you think you've got a problem, then the next thing is to very carefully probe it. Now, I generally carry a Swiss Army knife around with me, and so I'd pull out one of the blades and I gently push it in and see if the surface was going to give, if it was beginning to deteriorate. And sometimes in larger timbers and where there clearly is a problem, I might take out a bradawl or a pointed screwdriver, one that's been sharpened slightly, and just push it in to see a little bit further how far it will go in. So there are ways and means that are not too destructive. And if you're careful, you won't see where you've done that, but that's a way of doing it. You can try to get bits of the timber out and examine them a little bit more carefully visually. If you can get a bit of timber out of the surface, you can look at it. But again, if you don't know what you're looking for, that's no good. You can, we've spoken in other episodes about hammer testing, and this is where you tap a surface to see whether it's hollow or not. Well, you can do that with masonry, which is what we've discussed previously, render and masonry and plasters. You can also do it with timber. You can tap a timber and you can assess whether there's a hollow sound. And obviously, if there is, then you know there could be a void behind, which could indicate that there's rot behind the surface. But what Rich actually mentioned was these probes. Back in the day, a chap called Robert Demals, who I know, and talks with him at the moment about going and doing a talk for the Carpenters Fellowship. But Robert, he devised a method. He realized that as you go through a piece of timber, you have different resistances. As a good piece of sound timber will have very definite resistance. But of course, as it starts to deteriorate, that resistance reduces because the timber's beginning to break down. And so a drill will suddenly speed up through the softer bit. And then, of course, if there's a void, it'll just go straight through it. And so what he designed was a special drill, a micro drill that had a 1 millimeter bit. What you would do is you carefully apply pressure to put it in, and it had a readout on it as well, and you drill a hole through and it would give you a reading as to the resistance of that timber as you go through it. So that's another method of assessing the deterioration of the bit of timber you can't see.
Having drilled lots of timber in my, not necessarily structural timbers and things, but having done lots of work to timbers, I can absolutely attest to drilling through a particular chunk of oak or something and then finding a bit of, oh, actually that's gone through much easier in that bit. Subsequently then cutting the piece going, that's why there was an occlusion or there was some sort of difficulty or some sort of issue with that particular piece of timber. So I mean, brilliant device for it. I guess from my perspective, understanding the difference between drying shrinkage cracks, like we've spoken about in the first episode, and what is actually decay, they fundamentally look quite different, but I suppose to the amateur eye, they could look terrifyingly similar, I suppose, isn't it?
It is a matter of knowing what to look for. And what we can do is we're going to be talking about the differences between different types of rot and some of the characteristics. And what we'll do with the next episode, that's our next episode. And what we'll do there is we'll provide some links through to sites where you can see examples of these and learn a little bit more if you wish. And we'll we've got our own examples we can put up as images for those who are watching it on YouTube. I would say that if you're suspicious, don't try and analyze it for yourself. If you're not confident, if you've never done it before, you might be able to say, I'm fairly certain I've got a problem here, and I think it's rot of some description, but I don't know what. Then call in the experts, call in the independent experts, get a proper diagnosis of what's really going on and what rot it is and what's going on behind the scenes. And of course, to plug Rich's platform, Expertible, of which I'm one of the consultants, of course, I mean, there you've got a platform where you can go on it and subject to a very sensible fee. You pay your money over, you can choose your consultant, and you can have a virtual chat with that consultant, and you can say, I found this problem. This is what you can show them the pictures, and that consultant can help you, maybe not to an absolute diagnosis, but can help guide you and help you to determine what next steps to take.
So what we've touched on here is lots of bits about how to identify, or the ways to identify, or the ways to understand whether you've got any potential timber decay. We've covered what you can see. We've covered the hammer test and what you can hear. Stephen's covered what you can taste by the mushrooms that he's going to go cooking up for his lunch. But there is another sense here, maybe not. There is another sense here of our senses, which, not just touch, but also the sense of smell, because the distinctive smell of decay is one that you can almost sense when you walk into a room if there is a significant amount of that decay. And these fungi do produce the sense of smell. Now, I'm not sure the chemistry of exactly what produces the smell here, but there are lots of different methods about actually using that sense to sort of try to hone in on either where a source is or where you might have an issue. And Stephen, you've got some experience specifically of how they've actually honed that sense of smell, not for surveyors, but for particular animals to come and help with a survey. Tell me about that.
Yeah, well, I mean, a lot of people have said, oh, you can smell dry rot and this, that, and which is true, you can. However, what you've got to remember is that we can all have off days and we can have a cold or something. So as a surveyor, does that mean to say I refuse to do a survey because I've got a cold? No, it doesn't. I've still got to go and do my survey, but it just means I can't rely on smell. And so I don't think it's something that we should use as an absolute reliable indicator as far as we as humans are concerned. However, there are our four-legged friends, our canine friends, dogs, and they have an incredible sense of smell. And years ago, there was a company that's still going. I know friends of mine are in the company, Hutton and Rostron. They developed what they call their rot hounds. They trained the dogs to smell out specifically the distinctive smell of rot, mainly dry rot, but any form of rot. And they would take the dog round and it could smell out these rots. And they are very accurate and very useful. And it's non-destructive, of course. So when people say, you can't trust them to sniff out rot, yes, you can. They're very good at it. And it is a very good way of finding rot in hidden areas. They can sniff it out.
Well, folks, we've covered a huge amount in this particular episode about rots and the key takeaways. And we're just going to kind of summarize here before we introduce what we're going to do for the next episode, which is the next follow-on in this series. I thought I'd just tell a bit of a story in terms of how I've come to understand how timber decays. When I was a kid, I used to go and play on this kind of climbing frame, if you like, that someone had built before my time. And what I noticed on that was that on this particular climbing frame, there was one part of it that was rock solid, but there's another part that continued to decay and actually continued to rot away. And the simple fact of that was because the bit that didn't decay was in the sun. And actually it was the bit that did decay was shaded by the other trees around it. And it was continuing having to be repaired. And it was simply down to the rain would fall on the entire climbing frame, but because of the trees around it was shading the lower half of this climbing frame, it didn't dry out as well. So it was persistently wet. And that created the conditions for the fungi to grow on it. Whereas the bit that was in the sun all day, every day, dried out. So it got wet in the rain, dried out, no problem. And I just think that helps to understand the same principle is happening in our buildings, where you've got these 4 key criteria. You've got the mold spore that's omnipresent within our properties and our fungi and everything else. You've then got to have the persistent moisture, and it's not being able to dry out and it's trapped within that area. You've got the food source, which is the timber, and then you've just got a warm enough temperature for it to thrive. You remove any one of those 4 things, you no longer have a problem. And we're going to cover that in the next episode in terms of how you can go about doing that. We've spoken about ventilation. We've spoken about how you can, the issues with forced drying a material. And hopefully that's just sort of unpacked in terms of the understanding of what timber decay really is. What have I missed, Stephen?
No, I don't think you've missed anything. Learn how to identify the early warning signs. Now, this is whether you're a homeowner or whether you're a practitioner, a professional. What are the early warning signs? Learn what they look like. Go and see some. Go online and have a look at examples and find out what they're like. And then the important thing for a homeowner is learning to maintain the building envelope in good condition so that moisture doesn't get in the first place. If you're not getting moisture into that building, then you're not going to get rot. If it's not wet, it won't rot. It's as simple as that. So look at the moisture paths into and through your building. Understand where they might be. Look at the vulnerable parts. Where does all your rainwater gather? Maybe into a hopper where it might overspill and wet the wall. And are there timbers nearby that could rot? Understand where the vulnerable parts of your building are and keep an eye on those.
That's a lot down to the kind of penetrating bits of moisture. But then there is a slight complication, of course, the condensation aspect with roofs. So when you've not got sufficient ventilation in your roof, as we mentioned, the hygroscopicity of timber, if the humidity builds up in that attic space, then you can get rot in your attic space because of condensation, not necessarily because of a slip roof tile, for example. So it's understanding all the different methods and of where the moisture can come from isn't always necessarily a kind of a trapped moisture as such. It could just be underventilated.
Precisely. No, but it is understand your building.
Yes.
And understand how it's working and how you occupy it, how you work within your building. That's it for this episode, and that is where we've talked about why timbers might rot and some of the mechanisms that occur. What we're going to do in the next episode is we're going to take a bit of a deeper dive into the different types of rot. And we're going to talk about wet rot and dry rot and soft rot, the differences, what to look out for. We're not necessarily going to how to identify these rots in an absolute way, because I don't think we can sensibly do that. But what we can do is talk about the differences, and then we can point you to places where you can learn more if you want to. And the important thing here is to understand the danger of misdiagnosis and then what you need to do about it or not do about it. And we're going to also talk about, and this is the one thing that people will want to know about, is chemical treatment. Should you treat? Shouldn't you? Yes, no, maybe. Where do we sit with all this? Listen up for the next episode where you'll see Rich and I discussing chemical treatment, amongst other things.
So folks, hope you enjoyed that episode. This is all part of our timber series. If you like what we're doing here, please give us a thumbs up and don't forget to subscribe and hit that little notification bell, which will let you know when the next episode comes out. We can't promise that these episodes will be very, very regular. We're filming them when we can, when we get time to, and edit them, but you'll get notified when they do come up. But thank you all very much for your input so far. If there's anything specific you'd like us to cover within this timber episode, stick it in the comments below and let us know, and we'll see if we can get what we can do. Thanks again for listening, folks, and we'll see you next time.